So hello, this is only using transistor circuits, and today I'm going to show you how we can make a comparator using operational amplifier. So a comparator is a basic circuit that you can make using operational amplifier, and what it compares is it compares two voltage. So if you have two voltage source, one from a sensor and one reference voltage or fixed voltage source, and one is varying, so you can detect a change. You can detect if it's changed above a certain value or when it falls below a certain value. So it's very useful in many circuits where the voltage is varying, like in temperature sensors. It can be any analog output. So without wasting any time, let's make the comparator circuit. So for comparator circuit, we will take one op amp. So I'm using a simulation application called every circuit, and I will make the circuit as close to the practical one that we make on the breadboard. So this is the operational amplifier symbol. It has got one non-inverting terminal, one inverting terminal with a minus sign, and the non-inverting terminal is with a plus sign, and this is the output. So we will change its minimum output voltage to 0 volts, because in practical we have voltage source of 5 volts and ground. So we'll make it to 0 volts, minimum voltage 0 volts, and maximum output we will keep 5 volts because we have a 5 volt supply. So in reality, when you make the circuit on breadboard, the IC741 is the IC for operational amplifier, and you have to give positive to the 7th pin and negative, that is your ground, to the 4th pin. So and the output is on 6th pin, I think. So that is the IC part, and you can check the IC's pin out, IC741, which is a single op amp IC, and there is also a dual op amp IC called IC358, LM358. Yes. So without wasting any time, we will make this circuit. So we are using two voltage source. For that I am using two voltage dividers. As you know, we are going to make this circuit very close to the practical setup. So in practical we use two voltage source by making a voltage divider, two 10K potentiometers I have right now, which will give two voltage sources, V1 and V2. So these two voltage dividers will feed voltages to this top one will feed voltage to the non-inverting terminal, and this bottom potentiometer will feed to the inverting terminal. And now we want a voltage source of 5 volts. So we'll connect positive one end of the potentiometer to positive, another end to negative, and we will give it a ground. And now at the output of this op amp comparator, we will connect, let's call it a comparator because we are making a comparator. Even if it's op amp, we are not making it an amplifier, we are making comparator. So here my LED is also connected, and this is a series resistance of 200 ohms. This is also connected to ground. So the circuit is ready, and now you can see that both the potentiometers wiper position is in the middle. That means the voltage will be 2.5 volts even at the non-inverting terminal it's 2.5 volts, and even in the inverting terminal it's 2.5 volts. So the output must be 0. So that in practical is not possible because some voltage may be more and one will may be less. So the output may be high or low depending on the precision of the pots. So let's hit the play button, and as you can see that here the voltage is 2.5 volts and here is also 2.5 volts, and the output LED is off. So let's increase the voltage at the non-inverting terminal. So we'll increase the voltage at the non-inverting terminal, and it's increased to 2.6 volts and it's greater than 2.5 volts. So the output is, you can see that the output is high and the LED is on. So now we will drop this voltage below 2.5 volts and the output is low. When we will increase this voltage above 2.5 volts, the output is high, low. So in this way we can use 2.5 volts as a reference. So now what happens when we will change this voltage at the inverting terminal? So when the voltage drops below 2.5 volts, the output turns high and is dropped to 2.21 volts, and when the voltage increases, the output turns low. So here at this terminal when the voltage increases above 2.5 volts, the output will turn high. Output will turn low. When it increases above 2.5 volts, the output will turn low. And when it decreases below 2.5 volts, the output will turn high and the LED will glow. So you can see, you can also visualize it by graph. So now let's vary this voltage at the inverting terminal. So inverting terminal is orange, non-inverting is green, and our output is blue. So now let's vary the voltage at the non-inverting terminal. So we will sinusoidally vary the voltage, and you can see whenever it drops below the green line, the output will turn low, and whenever it increases above the green line is the reference voltage, and in opposite, if you want the opposite behavior, then you vary the wiper at voltage at non-inverting terminal, and you can see whenever the voltage drops, the output turns low. Whenever the voltage drops, the output turns high. So in this way the comparator works, and it's a very useful circuit. It's used in many applications, and you can also make a switching circuit using transistor, but by using a comparator you get more precision. That means even a change in 0.01 volts is detected and the output turns on. So even a change of 10 millivolts is detected by operational amplifier. And also we can set the reference voltage, whereas in transistor you need to, the voltage is increased about 0.6 volts, which is the cutoff voltage of transistor, and the output will turn on after that 0.6 volts. Whereas here you can change the reference voltage to whichever value you want, between 0 to 5 volts or between your maximum supply voltage and minimum supply voltage. So yes, this was the video. Thanks for watching. I hope you learned something and you will try this circuit on breadboard. So like and subscribe if you want, and take care. Good night or good morning. So goodbye.